All right, so what we have to do on page 7 is we have to take this fraction 1/8 or this ratio of 1 to 8 and we have to change it into a percent. I'm going to show you the long way to do it, and then there's an easier way to do it. Normally what we do to take any fraction and change it into a percent, or try to change it to percent, what would we want to try to do? Dan, you weren't here, but see if you can do it. What do you have to try to do first? And you'll see it's the way that we're going to try to do it is a little difficult. We have to take our 1 to 8 and figure out what percent that is. Juliana. We can't guess, guys. What? Let me go backwards for a minute. What percent is this? What percent is this? No. Right? So what we had to do in the past is we have to force this number into 100. You have to multiply it by 2, right? So understand that this is 30% and this is 30%. So now we're presented with 1 to 8. What should we try to do? Adam. Okay. Yes. And you got to figure this out, right? But what happens now, what makes this a little bit more difficult, is 8 doesn't go into 100 equally. We're going to come to that. We're going to come to the what's called the denominator into numerator method. But before we get to that, normally what we want to try to do first is this way. Abdullah, I know you know the constant. I know you know it, but how do you figure it out? Right, 8 times some number that makes 100 is really division backwards. So what we have to do is set up a little gazinta. Who goes outside? 8 times what makes 100, so 8 has to go into 100. And now, as you'll see, it won't go in evenly, so I know I'm going to need a decimal and at least one other 0. Raise the rock. And now I go through my division exercise, 8 into 10. That makes 8, right? All right, but let's work through it first, because then I'm going to show you the shortcut or the D into N method. 8 into 20. Mallory. Correct. Still not done, because you still have to keep bringing down digits until it terminates. Right, 8 times 5 makes 40. It terminates with nothing remaining and nothing but zeros to bring down, and that's our constant. Now we're lucky in that there's a 1 up top. So our constant in this case is the same as our numerator because we're multiplying it by 1, and what do you get? You get 12.5, which is your percent. What if this was 2/8? What would you do if this was 2/8? Just to see if you could follow through with the concept. No, 12.5 times something, but not 8. If this were a 2, I'll make it a 2. And you would get 25. What if it was a 3? 3 times, 4 times. So you get that idea. The other way to do it, which eliminates having to multiply after you get the constant, is do straight division. It's called denominator into numerator. Here's how it works. Using this box, I'm going to take this 1 to 8. I'm going to put it off into the corner here so we know what fraction it is. Out of 1 to 8, which is the denominator? 8. It's going to be 8 into denominator into numerator, which is 1. So I'm going to do an 8 into 1, and we could see right away that you're going to get a value less than 1, right? What now? No. No, because if you use this method, it's always denominator into numerator. And the way that Mrs. Singleton helps you to remember, and I like it, is when you set up your fraction, just think about 1 getting rained on because they're up top. They don't want to get rained on, so he's going to go into the house to be protected. That's kind of the way to remember it. So whatever number's on top, that goes into the house to get protected. Now, automatically, that's going to make a decimal. So I've got to follow up my 1 by adding a decimal and 2 zeros. At least 2. I might need more. But let's start with 2. You could add 3, you could add 4, you could add none, but I know I'm going to need at least 1 because 8 can't go into 1. So automatically I know that 8 is going to go into 10. It goes once. Put a 1 there, and 8 times 1 is, okay, and that's going to give me a remainder of, and guess what? I'm not done. I'm going to drop down another 0. So if you didn't create it, Mel, now you'd have to create another one. Because you got to keep creating zeros and dropping zeros until it completely terminates. Or repeats, which you'll see in the next exercise. It should work out to be exactly the same as 12.5%, but you'll see that when you have it as a decimal, you've got to convert your decimal to a percent. But we're getting ahead of ourselves. Let's complete this first. Bring down my 0, and we do 8 into 20. Everybody. Times how much, though? Okay, add your 2 at the top, get 16, and subtract again. Are we done? Still have to then bring down another 0, right? Got to create a 0, actually, and bring it down, because I only created 2. I need a third. But now you'll see it does go into 40 pretty evenly. 8 into 40 is, and it terminates at tenths, hundredths, at the thousandths place. It terminates. So now I have 0.125, don't I? Think back to what we did 2 days ago. How do you change any decimal to a percent? 2 places to the right, always. So you wind up with 12.5%. And it's the same as having it to do it this way. Okay? If you don't think that this is shorter and you want to do it this way, you could still do it using TRF. I just think in some instances you'll save time by doing it this way. It eliminates having to then multiply whatever your constant is. If you do long division like we did up here and you get this, well, you still have to multiply this by the numerator, which if it's 1, I mean, that's kind of easy. But if you have a 7 up here, now you got to do 7 times 12.5. It's another step. This way, it's straight division, and then just sweep the decimal over twice to the right. It was 1 over 8. I changed it to 1 to show you what you would do. Going back to the original, Mel, it's this. Okay? Let's try it with another one. Try 7/8. You want to try to do it by yourself first? All right. I'll pause this, and then I'll go. Maybe I'll call somebody up, and somebody can do it up here. But let me pause this. All right, Danny's gonna work it out.
Okay, so
Inside the house, who's outside the house?
8's outside the house and 7's in.
Okay, remember 7's getting rained on, so 7's gonna go inside the house.
And then 8 goes into 78.
Raise rock.
8 goes into 78 times, and that gets you 64.
Raise it up too so people see.
Yeah.
Hold on.
So then 8 goes into 67 times, and you get 56.
Yeah.
Then I add another 0.
Yep. Keep creating zeros, keep dropping zeros.
And 8 goes into 40 5 times, So I got 40, and I got 0.875, and then I moved it over 2 times. I got 87.5.
You got to move it over twice to the right. 87.5%. Now here's a good example where it definitely saves you time. Because if you start out, stay up here for a minute, Dan. If you start out with 7/8, and you don't have to write this down, but if you had 7/8 into 100, you get a constant here, same thing as 12.5, step aside so they can see it. Then, once you get that same constant, now you got to multiply 12 times 7.5, and there's more chances to make a mistake. So do 12.5 times 7, and you'll wind up getting 87 times 10, 87.5. It just takes an additional step. Give them a round of applause. Thank you, Dan. All right, you want to do the cat chasing its tail example? The cat chasing its tail example. 1/3. Well, I kind of want to do this together with you because it's different. I know you know it. You know it? How about you talk me through it? I'll talk. We'll work together. Come on up. Yeah, come on up. We'll work together. Problem B. Previous page. Yes. You could, sure. You could. Once you get the constant and they give you another one that has a denominator of 8, you can use that constant again. Yeah, absolutely. And once you know the constant, if you get 5/8, if you get 3/8, you'll then know to multiply whatever's on top by 12.5. Sure, you can do that. Okay, the cat chasing its tail example. You ready? You want this? All right. Here, it's right neck. All right, first.
Wow.
Set up. Who's in, who's out? You're going to have to write a little smaller, though. Be careful, because you're going to need room. Let her do it. It's okay. If we run into the exercise board, it's fine. Yeah, we need a rock somewhere.
Oh, you need a rock. Page. And then you.
Well, wait. Go back. 3 into 10. Oh, you're doing that now. 3 into 10. Go 3 times, right? Yeah, you see? You see that you always get. You always get a remainder of 10, and you always get a number of 3, right? So the 3's go on forever, right? Cat chasing its tail. 3, 3, 3, 3, 3.
So 0.4? Wouldn't it be 0.4?
Close. You do want to round it. Sometimes they tell you not to round it.
Wow.
They'll tell you just to keep it as 33.3 repeating percent.
Testing.
But if you had to round to the nearest whole percent,
Yeah.
hey, what's it closer to?
Oh, 0.4.
No, that's the nearest 10th percent.
30.
No.
35.
Either 33 or 34. Those are your
34. 34.
Look, watch. What number goes here?
3.
Is this number greater than 5
No.
or less than 5?
It's less than 5. Yeah.
Okay. By the way, if I mic you up, don't put the mic that close. Nobody's going to even hear you. It's going to be too loud. It's going to blow out their eardrums. All right, I'll take this. You're all tanked up. All right, everybody, try the next one. Try the next one on your own and bring it up when you're done.